Welcome back to Bal Vigyan Bharati with Abhilash Sarkar. Now we will next move into the problem number 13 in twin statistics. 13 problem, a U-tube with both ends open, a U-tube with both ends open to the atmosphere to the atmosphere is partially filled with is partially filled with water partially filled with oil which immiscible with water is poured into water is poured into water until it stands at a distance of it stands at a distance of 10 millimeter above the water level on the other side meanwhile the water rises by 65 millimeter from its original level. It is given C diagram. Okay. The density of the oil is how much? The density of oil is how much? Now draw the picture. Draw the U-tube. There are two sides of U-tube. A U-shaped tube with a two-arm vertical. Okay. Now water is up to a level this and this is up to this. Now I will mark it with this angle slant. Water is marked with the opposite angle slant line. Okay. So, or rather I will make it cross. so it will give you a much clear picture. So this part, this is point A, this is point B, this is point C. I will mark something here. I will explain what is this line. This is point, the reference, if I say the state reference, this could be some other point, this given as F, this point is E, and this point is D. This is the last level of water. So this is final level of water, final water level. This is initial water level. So as per the question, this is 65, and this difference, that is not in scale, but still the difference of their final, when it is come into steady state, the difference between the level of water to the level of oil is 10 mm. So this is 10 mm, this is 65 mm. Okay, and this part of your work is water. So these are the the thing given in the picture. Now, before I start, the first thing is that, what I said, the point which is intersected by a horizontal line to the two vertical of the U2, where the fluid are same, will be at same pressure as per the, so where this BC line, if I say, across it the liquid is water, though this is same. So in the horizontal line which is cutting this two arm, if I take pressure here and pressure here, so that means PB is equal to PC. That is as per the procedure or the concept. This concept will be applied or can be applied in any case, anywhere in YouTube problem. So this is the basic thing. So this is as per the concept, it always be true. Point which is cut by a horizontal line, if contain the same fluid, will be at same pressure. Okay. Now, this dimension is given, this dimension given. What about this dimension? What will be the dimension? Can be concluded or not? What is this dimension? Now to get this, when oil is poured, initially the water is filled in this U2. So what is the situation? The U2 is something like that. When only water is there, it must be in same elevation. This complete thing will be in same elevation. Okay. So this is the initial position that I said, this is the initial position. Then after, when oil is poured, this has gone up. How much? 65. This has gone up. Okay. Now, as this oil is replacing water on the other arm, so when it is oil is poured, it is poured such a way that this final steady state condition will happen when the difference of the level will be 10. Then I will stop. But this part, as per the diagram, the other arm of the U2, just crossing uh, this has actually it is somewhere here as per the drawing. I am not at the curvature itself, it has somewhere there. Let me correct this drawing because as per the drawing it will be easier for me to make you understand. Let me draw it once again. So this is the water, after crossing the curvature at some point, this is B, this is your C, the initial point is said to be in D, this point is E, and the reference point is F. What I said, this is 10, this is not to scale, this is 65, up to this is 65. I mean to say, if I take this dimension, it is 65. I was asking about this dimension. What is this dimension? Now, when the oil is poured, what I am saying, this was the earlier case when there is only water. This must be in equal dimension, both the cases. If I take some reference from here, the arm height will be same. When you started pouring oil, and at some point where the oil and the water difference is 10, when you reach that, we stop pouring water, and that is the steady state condition. There could be some other steady state condition, but the pouring of oil would be stopped when this difference is achieved. Now, this is dispersing water from this arm and it is pouring in this arm. Unless it is completely dispersing water from this, we cannot conclude, we can conclude that whatever water column is rising there, it is displacing that much water column because the cross section is same. So what is the effect will come? Whatever height of the water will come down here, it will the same height, it will go there. Okay, so that means if I say, so to raise at 65 height of water, it must that this part, if I remove it, this part will come to its own. This is initial, this is the initial state, initial level, this is final level. So where this water will stop, if I remove this oil, this will come down to this initial phase. So then this will come down how much here only, and this much height will go there to balance this. So how much it will come down to that initial 65. So then 65 only will come down, will to equalize this length. That means I am raising 65. That means 65 is dispersed. So when I leave it, so 65 will rise there. So that means this side, if I take it from the last level of water, I'm just referring the same fluid, because my theory is that in same fluid, in horizontal line, the pressure will be same. So that means I am in the same liquid level. So whatever disbursement, if I remove it, whatever height it has reached, it will come down. So this 65 will accommodate here. So that means this height also of 65. Understood? Because whatever be the height of the liquid, if I remove it, this will be equally distributed apart from this horizontal line, equally distributed. So if it is initial line 65, so below than that up to this must be 65, because this will balance other side, then only it will be equilibrium if it is a only water is there. Understood? It is not much difficult to understand, but sometimes people may confuse what would be the height. For same liquid, the disbursement of the height will be replaced by the same amount of same fluid. So if I go from initial state to the final state by 65, that means I am dispersing 65 further. So when it will come down, it will match the initial state. So that means this will add up there. So this height must be with reference to this line will be 65. Understand? Now this is very much because this data may not be there in the drawing. It was there in this sum. It was there. It was written, but I intentionally am not written to make you understand. Even if it is not given, you can get it your own. Okay, this has to be very crucial point. Now, apart from this will be just the similar one. What is that? The atmospheric pressure. It is an open tube. Atmospheric pressure on this, it will be the pressure at B. If I consider it is atmospheric pressure plus the oil height of the oil AB into rho of oil into G of oil, and on the other side PC, that means atmospheric pressure will definitely be there, plus height of the water column is what? 65 and 65 both. So that means 130 into rho of water into G. Fine. So PP same, GG same. Now AB is how much? 65, 65 and 10. Okay. So 65, 65 and 130, 140 into density of rho oil into 130 into density of water. You can see the all dimension. This is in mm, this is in mm. So if I consider density of water be 1, density of water be 1 gram per centimeter cube. That is the standard one. So rho of oil 130 by 140 into 1. So that means 13 upon 14. You can convert it into decimal, that is up to you. But this is the value and it will come in gram per centimeter cube. If it has to be contained in SI unit, only thing is that you have to multiply it with 10 to the power 3 kg per meter cube. This will be the answer. Okay. Now moving to the next problem. Find X so that fluid remains in equilibrium. Fluid remains in equilibrium. Why that? So I have to draw the picture where the equilibrium of a liquid is disturbed by other fluid. So the initial condition is there is a U2 of this cell. It is not basically the complete round is coming at the bottom, rather and what is said, it is a sliding face is there, and this is sliding boundary. Sliding boundary. What does it mean? It means there is a rigid plate which is separating two liquids in either of the arm. One initially this was the liquid in the other side, this was the liquid in this side. There are two different liquid there. The height of the initial height is 9 centimeter on the both arm. This also 9 centimeter. Okay. The density of this arm liquid is 1 gram per centimeter cube. In this rho is 2 gram per centimeter cube. So rho 1 you can say this is rho 2. Okay, now this has kept with some force, you can say this sliding boundary may be kept with some mechanism in this position, where initially those liquid being separated by this sliding boundary, okay, and the both arm, the liquid column was 9 centimeter. But when it is, that force is removed from the sliding boundary, so as this is having more density, this column of liquid is same, this will create more pressure. So in turn, as the cross section of this arrangement is uniform everywhere, that we can take in consideration, even though it is not said, by from the diagram you can say the cross section is same. So force in this sliding boundary F2 minus F1 will be resultant force. If a resultant force is there, that means force created by this pressure in the arm 2 into the cross section, and the pressure from the other side is this is, let's say, F1, this is, let's say, F2. So the resultant force is delta F. That definitely there will be resultant force, because P2 is more than P1, and clubbing with the cross section, it will give a force there. So once I leave the mechanism, the thing will move this side. So the next equilibrium that will be probably will arise, it will come to a equilibrium after so many of cycle, because once I leave the force that is keeping this liquid column equal, once I leave, for first instance the force will go there, but due to the momentum of the liquid column, it will get a velocity, and the velocity energy may rise this liquid column something more than the static equilibrium. So that will get some extra energy and it will come back. So slowly it will come down to the equilibrium. Once it will come down to the equilibrium, the situation may arise something like that. What is said? The liquid column in this, the sliding boundary somewhere will reach here, and this arm will raise a height of this much, and this arm will come down to this height. Okay. Okay. So now, if I say this was the earliest stable condition under the force, where some mechanism has stopped the sliding boundary to move, in that condition this was the stable condition with the external force. Now when it is removed, it is getting an advantage of height of x above the initial equilibrium, when it is come to a steady state. And so similarly, if it is going up of x as the same liquid, the level down on the other arm will be the same, this much x will come down. So this is the ultimate position of the liquid when this sliding boundary come to a static state, static equilibrium. Okay. Now what I said, the pressure across a horizontal line cutting the two arm of a U-tube, if the liquid or the fluid are same, it will be under same pressure. If it is P1, it is P2. So in this point, P1 equal to P2. Okay. So what is P1 here? P1 is atmospheric pressure on the top. This also comes under atmospheric pressure. So this is P0. P1 is P0 plus, what are the liquid column? This x plus x, 2x, height into rho. this having density rho, single row, that will come later, rho 1 into G. So on the other arm P2, P0 is the atmospheric pressure, plus there is no height of advantage, this is only pressure, so there is no portion of liquid that is but thing is that sorry I made a mistake here. What I said, P1 is equal to P2 if the liquid is same, but here liquid is different, so I cannot put this formula here. So you have to be cautious when you are taking that decision. P1 and P2 if I say equal, that the liquid must be same, but here liquid is different. So where the pressure is same, at this point pressure is same, or rather you can say in this point, as the cross section is same, force is same, then only it's equilibrium. Or in turn, if force is same from this side, F1 is the force, this side F2 the force, this is under equilibrium, then only F1 is equal to F2. So if F1 is F2, so P1 here into cross section is equal to P2 here into cross section, should be same, because cross section along this this is uniformly having uniform cross section, I mean. So this will not take a part. So only thing is that P1 is equal to P2 at the across this sliding boundary. Now it is okay. Now it is, if it is P1 and P2, so what is the pressure here? What pressure I will get at, if I consider the bottommost point, this will be the in same pressure that will be transmitted this side. So P1, when it is up to this height, if I consider, so this means P0 plus the height is how much? 2x plus whatever height you will consider this h, 2x plus h into rho 1 into G that is equal to pressure here P2, means P2 is equal to P0 atmospheric pressure plus your height is h into rho 2 into G. Okay. I am considering the lowest point. Here pressure must be same, because that pressure also is transmitted this area. So if I take the highest pressure here or in this zone, you also can do this here or this here, whatever you take. Okay, but here it is unknown, whether you take up to this is h or up to this is h, this doesn't matter. So I am taking the lowest point where pressure is same this way, and that same pressure will be transmitted this way. Then that's why this is in stable condition. Okay. Now P0 will not take part. G cancelled out. So ultimately 2x plus h into rho 1 means the density in this arm. This is rho 1. So this is 1 gram per centimeter cube is equal to h into this arm, it is 2. Okay, into G cancelled out. So that means 2x plus h is equal to 2h, or 2x is equal to h, or find x. So find x is equal to h by 2. Now initially this is your 9. Okay, so instead putting it in form of h, rather up to this was 9. Sorry, I have to change a bit. This is okay. Instead of taking it h, don't take it other means parameter. Initially this is 9. Okay, so while I calculate P1, this is P0 pressure plus the height that will be added to this 9 will be the only x. If I take up to this is 9 now, so x will height, so x will go up, so this will height will be 9 plus x. Instead taking another parameter, already 9 is said in the first figure, so how much is increased, this will be added up to 9. Okay, sorry, pardon me. So and the rho is here is 1 and your g. In P2 this will be P0 plus this is 9, so x similarly will come down because x is rising up, so x, because this initially that is said to be in same, so that means it is equally transmitting, there is no compression in the fluid, so whatever height it will gain, the same height we can assume it is come down, because these are incompressible fluid. Okay, so this is equal to 9 minus x, the height will be 9 minus x into this part, this is 9 minus x, this is 9 plus x. Understood? This is 9 plus x, this is 9 minus x. So height is, and your density is 2 into g. So P cancelled out, G cancelled out. Ultimate one is equal to 9 plus x into 1 is equal to 9 minus x into 2. So now 9 plus x is equal to 80 minus 2x, or 3x is equal to 9, or x is equal to 3. This is in centimeter. Okay, so this will be the centimeter. The x value is centimeter. Sorry, I mistaken sir, because the data was already available. This is 9. So I need not to take any other parameter because that will move you to other direction. So rather you can understand, this is very easy to answer because these are incompressible fluids. Whatever height the other fluid will gain, it will sacrifice the same height down and it will be stable. So the stability condition, the pressure at the lowest point will be same. Okay, as because the sliding boundary is in stable condition. No. So I move on to the next problem, that is problem number 15. In a U2, in a U2 is shown in the figure, is shown in the figure, water and oil are in the left side and right side of the tube, are in left and right side of the tube respectively. The height from the bottom for water, the height from the bottom for water and oil columns are 15 centimeter and 20 centimeter respectively. The density of oil is find the density of oil, take density of water equal to 1000 kg per meter cube. Now the drawing is something like that. centimeter, 20 centimeter. There is a sliding boundary given. This is different weight, so I'll make it cross. Okay, so this is sliding boundary and this is the other liquid on the other side. So this is the drawing. This is, their side is water, this is oil. So these liquids are immiscible because the density of oil is less than water, so it will not mix. So as density is less, it is having higher length of the column. It is understood. In the YouTube, this one in the figure, the water and the oil are in the left side, right side of the respectively height of the this and this. Now find the density of oil. Now it is as it is in a steady state, static equilibrium. In this part, the pressure from the both side is same, P1, P2. Okay. So now if it is P1 and P2 same, P1 is equal to P2. What is P1? P1 is the atmospheric pressure, is with straightforward, and the H rho 1, H1 rho 1 and G is equal to P0 plus H2 rho 2 into G. So as you know, these are not taking part, this is not taking part. H1 is 15 into rho of water is 1000 10 to the power 3 is equal to H2 means 20 and rho 2 you have to find. So rho 2 straightforward, it is 15 by 20 into 10 to the power 3, 5354, that means 0.75 into 10 to the power 3 kg per meter cube of the density. This is very straightforward. With these similar things we have did already, so there is no much harm in doing the straightforward. So here I will finish out of this session. In the next session I will move on to the problem number 16 and onwards. So thank you for now. I am going slow as because this is a new subject. When I will come back to this subject again with few more concepts on the sum, because these subjects will rotate. Once I will finish up one part of the subjects, then I will move on to the similar subjects again with some more advanced theories and sums together. So this will go in continuation. So don't miss any of the episodes in similar subjects and follow the channels constantly so that you will be able to catch up any point of time. Okay, so thank you for now.